Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through odd and even functions. So a function is said to be even if it's symmetrical about the y-axis. This means f of negative x equals f of x. A function is said to be odd if you reflect it about the x-axis, then the y-axis, or the y-axis, then the x-axis, you get the same function. So mathematically, a function is odd if this is true. F of negative x equals negative f of x. So this probably doesn't make any sense, but don't worry, we'll go through some examples to make it clearer. But firstly, I just want you to note where the terms odd and even come from. They come from the fact that a function with only even powers of x is an even function, and any function with only odd powers of x is an odd function. So I can tell that this function here, because it only has even powers of x, 8, 4, and this is actually 2x to the power of 0. So because this function has only even powers of x, I know before graphing it, it's going to be an even function. The second one, I have x to the power of 1 minus x to the power of 7. Only odd powers of x means this is going to be an odd function. Now this function here has even and odd powers of x. It's actually going to be neither. So most functions are neither even nor odd. All right, let's look in closer detail what it means to be even or odd. So let's use the definitions on the previous slide to determine for each of these whether it is an even function, odd function, or neither. So this function is symmetrical about the y-axis. So it must be an even function. Even functions are really easy to determine. Now, we knew it was going to be even because it's only even powers of x. X to the power of 2 and 4x to the power of 0. So let's look at this function here. So if I were to reflect this function about the x-axis, I would get this. So the blue function is a reflection of the red one about the x-axis. If I now reflect this blue function about the y-axis, that point goes to there, this point stays where it is. If I reflect the blue one about the y-axis, I get the red function. So if I take this red function, reflect about the x-axis, I get that, and then if I reflect that about the y-axis, I get the original function. That's what it means for a function to be an odd function, and once again, we knew it would be odd because we only have odd powers of x, 3 and 1. So what about this last function here? Well, it's clearly not symmetrical about the y-axis, so it's definitely not even. Is it an odd function? Well, what if I were to reflect this about the x-axis? If I reflect the red line about the x-axis, I get the blue line. If I now reflect this blue line about the y-axis, well, this point would go over here. This point would stay where it is. I'd get that there. So this function, if I reflect this red line about the x-axis, then the y-axis, I don't get the original function. So we knew it wasn't even, and we've now found it's not odd. So this function here is neither even nor odd, and we could have predicted that because we've got x to the power 1 here, 3x to the power of 0 here. We don't have just odd powers of x or just even powers of x. So how would I actually show that this is even, this is odd, and this is neither? Well, you use the mathematical definition that I gave you on the previous slide. So it doesn't matter whether we call the function y or fx. So this is f of x. So f of negative x, all I do is take my function, and everywhere I see an x, I replace it with negative x. Note, whenever you're substituting a negative into a function, use brackets. So negative x squared, that's negative x times negative x, it's just positive x squared. F of negative x is this, which is the same as f of x. So I've proved mathematically that this is an even function. So we can do something similar to prove this function is an odd function. So it doesn't matter whether I call it y or f of x. So f of negative x, I just take each of the x's and replace it with negative x, and whenever you're substituting a negative, you always need brackets around it. So negative x cubed gives you this. negative 4 times negative x becomes a positive. So note, this is equal to negative, and this is f of x. So I've just proved that f of negative x equals negative f of x. I've proved that this is an odd function. So hopefully you're starting to see why even functions use even powers of x and odd functions use odd powers of x. Negative x to an even power gives you positive x to that power. Negative x to an odd power gives you negative x to that power. So let's look at this function here. How do I prove that it's neither? So I'll call this y f of x. If I substitute x for negative x, I get negative negative x. This becomes a positive. So note, this is not the same as the original function, so that proves it's not an even function. It's also not the same as negative f of x. Negative f of x would be negative 3 plus x, not 3 plus x. So I've just proved this is neither odd nor even. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.